All right. So what I mentioned, Kohore. Okay. First, let's take pi fella. No, let's take an angle. We say theta equals to pi, and then all over the 2. That's one. And then the next one we take r. Let's use the value we had, r equals to 2. And now we change. We now say r equals to. Let's make it well. Let's just say cos. Okay, I'll emphasize the one, and then cos of theta, 1 theta. I'll put 1 there. And then let's have another one, r equals to 3, and then cos of of 3 theta there. And then let's have another one, r equals to, maybe I can make it 7, and then really cos of, let's make it 5 theta. And then next to that, let's have something similar, sine. We say r equals to 1, and then we've got a sine. I'm just emphasizing those numbers so that I can talk about them. And then 1, and then theta. It's not a 10, please. And then finally r equals to 3, and then we've got sine. I can use 3 or any odd number of my choice. Let's use 7 theta for now. Yeah, let's use 3 so that you can relate. 3 theta. And then the other one, we've got r equals to 7, and then sine, and then of 5 theta. There we go. All right. So, yeah, because Maban, when I was asking, Kira, how deep did you go, you guys? Now, wait a minute. It's because I was worried about, because other things, Dibata calculator. All right. Unless they give you ample time, or they're like, oh, you guys, your brain is a calculator brain, new generation.
Yeah, we get.
Yeah.
I think we get 1 hour for both. No, for each for calculus and algebra.
Yeah. All right. Yeah. Okay. These ones are odd angles. Do you see that? These are odd angles.
Yes.
Look at that angle, 1 theta, 1, 3, 5. Those are odd numbers. Same thing, cosine. All right. So when we've got the polar coordinate, all right, let's pretend this is just a polar coordinate. I'm just gonna put the line here. Let's just pretend the polar coordinate, please. All right. So I get it. I'm kind of doing it from, it's like from the memory kind of standpoint of it. Now, yes. Tell me these two equations, the blue or the yellow. How many terms do they have on the right-hand side? Yes, 1 term. Robert?
Yes.
So this is not the limestone stuff. You good?
Yes.
Yeah, this is the one that forms, I call them flowers. Dito forma the rose. Yeah. All right, fine. So we know that because, okay, let me put it there, get 1 term to help us remember. Because you are not doing enough points maybe sometimes to give you a figure. So, number 1, cos Kimo, let me put 0 degrees. The course, the flower, one of the flower, that's where it's gonna start. It start there. Every time course it
because of the restriction.
Restriction.
Is it because of the restriction causes 0 to 180?
Yeah, actually, and under all cases, it always stays there, no matter what equation I give it to you.
Okay.
Yeah, to form the flowers. If maybe the two, maybe sometimes, you know, like all those things, you wanna go spin around, all those kind of a thing. Where is it? Yeah, wherever it is. But it will come back to that one where you started. Can you see that?
Yes.
Yeah, it will always start here. Go to the first one, get this, it's here. Then you can have plenty, da. Right.
Yes.
But sign does not do that. So here is the start for sign. Sign start at 90 divided. Do you see those coefficients? Theta 1, 3,
Yes.
5. Yeah, maybe let's write this as sine B theta. It's 90 over the B. Whatever angle you're getting, let's take number 1, inally 1. So when I say 90 divided by 1, well, it's 90, but remember you can use pi, it's fine. I mean pi over the 2, sorry, so to speak. All right.
Yes.
So that means 90 divided by 1, 90. So that means it will start here. You see?
Yes.
For the first one. But for the second one, because we've got 3, the coefficients of theta, it will be 90 divided by the 3, which is 30 degrees. Let's just say maybe 30 degrees is somewhere here. Let's just say from there is 30 degrees. Then the first one will start from here. Okay, now you understand where sine starts. You must say 90 divided by the coefficient of that one. Okay. So kitty flowers, that's all. Don't worry. Now, I gave you the start. Kari, I'm giving you the odd number. Number 2, you need numbers. Number of leaves. How many leaves are there? All right, okay. I'm just going to put it as LF, don't worry. Number of leaf, yeah, number of leaf. Now, because of odd angle, all right, remember kisebedise coefficient ya theta as a B, ne?
Yes.
Yeah, it will be twice B. I'm sorry. It will be just the B, for both of them. Okay, leaf, when it's odd, it's just the B. So that means A cos 1 theta. Inally 1 leaf. That's how you find it is going to come up here. It's going to be like that. Just a circle. Resharp, ne?
Yes.
I meant your cos. Come on, I'm drawing it in the wrong side. It should be here. And then your sign, if it gets a 1 sign, because it's positive, just there. That's it, it's 1. All right. Now let's go more. The next one. The next one, the next question, the second one. In only 3 leaves, can you see that?
Yes.
So that means I must have 1. I'm just going to draw them normally, and then another one, and another one. That is the third. There must be 3. But the question, How do they space up? Where will the next one be located? Do you get what I'm saying?
Yeah.
Yeah.
Yes.
Number one, I told you where each one starts, sine and cos, the starting leaf. Number two, I'm telling you how many number of leaves are there. So you already know more cos. The first one, more 0 degrees. Where will the other one be located? Maybe I can call it space. Spacing. Spacing of leaves. Spacing. Spacing, we use 360. We divide it by the B. This one will never change even for both of them. It's the same thing. It will be 360 divided by the B. So let's take number one. Oh, no, not number one. Actually, you can use number one. Let's try number one. Number one, we say, okay, the coefficient is 1. There will be 1 leaf. That's the first one, 1 leaf, correct?
Yes.
Number 2, cos, where does the first leaf start? It starts more, cos 0. Then you'll be like, okay, guys, Kitloba leave the first leaf. I'm just drawing it like that for now. And then Kiri, where will be the next one be? We take 360 or 2 pi divided by 1. The next one will be 360 degrees from the 0. Come on, when you go 360 from the 0, you back where you started. It's just going to be here. Do you see what I mean? Yeah.
Yes.
Hence, it's just there. That's it. Good. Let's do the second one. The second one, we know it's 3 leaves.
Yeah.
The first one must be more cos 0. Good. Then what will be the second one? We say 360 divided by 3. Is it 120? Yeah, because 3 ukena I 1 ko 3 more 6 I 2. So it's 120.
Yes.
All right. So 120 should be maybe say somewhere around here. Do you see what I mean?
Mm-hmm.
And then 120 plus 120, keep going, 240, ne? Yeah. Then I think, because somewhere it will be 245, somewhere around there. Then the other one, it will be somewhere there. So Marahari draw, because the way they form, they kind of form like this. I believe it comes like that. Because it's ansikalem, ikupuke. And follow that curve, and then it goes like that, then it's back where it started. Rishabh,
Yeah.
if you don't get them right, do like how I did it. I write those balloons first.
Okay.
Yeah, because they don't mind, they just want you to get it right, because any curve, and it's one smooth curve like that, the other one is one smooth curve like that. Then the other one is one smooth curve like that. Can you see? And then they are compared. Yes. Yeah. So they all meet cos center muna. All right. Now let's go cosine. Cosine, it's the same thing, but arinke aya 3. All right. That means I need to take the angle. I say 90 divided by 3. What is 90 divided by 3? Can I 30 degrees? Am I right?
Yes.
Yeah,
Yes.
so 30 degrees, maybe it's somewhere here. All right. It's 30 degrees. So the first leaf will be just right here. Now, the spacing, I need to take 360 divided by 3. The spacing, key 100 and what? And 20, isn't it right?
Mm-hmm.
All right. Actually, it's about the same thing, this, but you just twisted it. Let me do a Hong Kong here. It's like you took that one, you kind of twisted it a little bit like that. So that this one is at what's it, 30 degrees. It's about in that manner. All right. So, all right, what do we do? Once you figure it is 120, the angle you are at, keep 30. So it's 30 plus 120. I think it's 150. Am I right?
Yes.
No. Yeah, 150. Because here it will be like Boma 135. So the 150, maybe it will be somewhere here. So then the other leaf maybe could be here. All right. 150, you are at 150, put 120. Is it 270?
Yes.
All right, 270 is the one right at the bottom here. Then the other one will be here. And please, no hurry. The leaf itakalaka, the way I'm starting red, and then it will spin like that, and then it will come like that. Did you get the idea, ne? All right. You can do even, let's say okay, let's say this one. In a 5, they will start from 0. But then I take 360 divided by 5 to figure out where another one will be, and so on and so. The spacing. Rishabh, I guess.
Yes.
Do you see why I was asking you, or do they allow calculate when you're working out the spacing? Yeah, sometimes check out that 360, I guess 75. When I go 360 and then I divide it by 5, check what it becomes. It's 72. But what if now I've got 360 and then instead of having 5 leave more 5 equal 7, then I divide it by 7. Then check what happens now. Now you got 51 point something. You'll be like, you can't get this from your head without the calculator. That's why I'm saying they'll give you numbers which are workable, easy to work with, special angles and so forth. Rishabh, ne?
Yes.
Yeah, like the one I just did them without that one. All right. So now, yes, while I'm still on this, what if the angles were even numbers? If the angles were even, instead of 1 theta, 3 and whatever, remember we make, in other words, the working words in cutting that formula, I am making that B an even number. Then the number of leaves will be twice the B. That's all you need to remember. So which means if you give me R equals to, yeah, I needed to say something about the length. Let's say I've got 3 and then cos of, let's make it 2 theta now. If get 2 theta, that 2, I double it. There are 4 leaves. Okay?
Yes.
There are 4 because it's an even angle. So which means I know it like kalama. Maybe it will be 1, maybe it will be 2, maybe it will be 3, maybe it will be 4, like that. Because the spacing, I must say 360 divided by 90. Am I right? Ne?
360 over, is that 360 over 2?
I'm sorry.
Over 2, 180.
No. Yeah. I'm thinking in train. First number of leaves. I wanted to do the spacing.
Yes.
Remember? Yeah. No. We are right. I mean, with the course, I'm thinking side. So we know we started. So it will be 360 divided by the 2. 180. Ne?
Yes.
Yeah. No. Did I go wrong somewhere else? Let's back off here. Yeah, because we must have, when it's even, it must be 4. It must be twice that one. It's twice number of leaves there. All right. Oh yeah, no. Sorry, it's me. Yeah, I got it. Sorry. Then because sine equal to 360, I should have said it here. Sorry. Yeah, because more not also even 3 you must say 360 divided by the number of leaves. I'm sorry about that one. Nah?
For the odd.
No, for cos. Okay, let's recap. The spacing sa cos ki 360 over the number of leaves. Okay?
Yeah.
Okay, let's say over the leaves. Rishabh, ne?
Yes.
And then this one, it must be 90 over. You remember we were using the B.
Yeah.
Yeah, I should have written it in this sense, sorry. Number of leaves. Sign it's by 90 over the leaves.
Yes.
It gives you the starting, and then utlo batla le spacing. All right?
Is this not the spacing, the 90 over the leaves?
It is and it is not. Why? Let's put it this way. The number of leaf mona ke 1, mona di kae? D3, mona di kae? D5. Akerne.
Yes.
All right. So you know the leaves tsa how di kae. Ha ke batla space, I must say 90 divided by the B. In this case, it just happened where the number of leaves are the same as the B.
Okay.
Do you understand what I'm saying?
Yes.
B and the number of leaves had it one, but di ka tshwana some other times. In the odd, the B will be just the same as the number of leaves. So that's why it's kind of like I'm using them interchangeably.
Yes.
Okay. Now, arutwane first. How do I get number of leaves in the odd? The coefficients of the theta in both cases. Rishab?
Yes.
Now, let's not talk about start. Let's talk about the spacing. The spacing should be 360 over the leaves.
Okay.
I'm not talking about where it's going to start. Cos it ko 0. In other words, how far is the next leaf? 360 divided by the number of leaves. Come on. It should make sense to you if we've got a line like this line. This entire line, it's 360 meters. And then you want to break this line into 4 equal pieces of equal length. Wouldn't you say 360 divided by 4?
Yes.
Yeah, because the entire length, because remember the whole circle ki 360 kaofela. Ki tshwantse ki break it into 4 let's say intervals, 4 sections that it leaves. So it will be 360 divided by the leaf. That means the distance from one leaf to the other. I'm not talking about where does the other one start. If the other one start goes 0, 360 over the number of leaves will tell me where the next one is located, the next one is located. Do you get what I'm saying?
Yes.
Good. That's the spacing. 360 over the number of the leaves. Right. That's spacing set 100%. All right. Key for both hakere.
Pardon?
Are you lost? I'm saying the spacing.
No.
It's 360.
Yes, I understand.
360 over the leaf, whether ki cos or ki sine.
Yes.
But where the first leaf starts, with the cos, it must start by 0. Then you can add that spacing, the 360 over the leaf. We good?
Yes.
But where the first one start, your sine, it start by 90 over the B, not the leaf. Remember, the B can be equals to the leaf. In this case, in the odd, the B is the same as the leaf here. That's why. Aha. But then Harriet said the even numbers. All right, let's just do the cos also this side here. I mean the sine one. Rebel R equals to 3 and then sine of 2 theta. I'm just going to write it one step at a time. Number 1, number of leaf. I will say it's 2 times the B. Let me put it like that. Kiki the even, this one. Risharp, ne?
Yes.
Number 2, let's do the space between the leaf. Space equals to 360. I think I can later, but 360 divided by what? The number of leaf, meaning by 2B, because 2B give the number of leaf. 3. First leaf starts at 0 degrees. Regrand, ne?
Yes.
Aha. Now, the same story, I'm just going to copy that so that Gibe class has sign. So what I'm putting in the box is going to be signed, but I need to modify it. The starting, well, what? It's not a 0. We change the starting, yes, sign. We say no, out. Starting is 90 over the B. Waibona. Do you see what I'm saying?
Yes.
Yeah.
Yes.
This is for the even. But let's say you had the odd. How nearly odd? Check out the number of leaves. 2 what's ama? Iba B. So limona noto divider ka B. You get what I'm saying? Limona netlots if nearly odd yards or mona. Do you see now the leaf diba B? The B, you see, that's what I meant. Can you see? Do you see the difference? Is it clear now?
Yes.
All right, perfect now. Okay, all right. So let's work with this one here. Let's work with this one. Related those steps. All right. So yeah, I need to remove all of that. All right. So let's just do those now. First, I'll be saying, yeah, there was one thing I said I needed. Let's put it, I'll call it the 4th one here. Okay, let's put it at the bottom. The bottom one. The length. Leaf length. How long is it? The length of it. All right. So that coefficient, that 3, it's always length all the time for both cases. So the leaf in this case will be like 3. So that means I can lay that space. Then I'll say this is 1, 2, 3. This is 3. So the leaf yaka it'll fit momo 3. Inali length ya 3 from the original. 1, 2, 3. 3 from the original. And that's the part so last time I said I needed to add that one. Rishabh, can you say it's 4 basic keys? Can you see that?
Yes.
Yeah. So let's talk about this one. Sign. Number 1, I need the number of leaves. So I'm going to answer that in red. In my case, I've got 4 for number 1. We good, ne?
Yes.
The spacings of the leaf is going to be 360 divided by 4. Kimkai, give 45. Is it 45?
360 divided by 4 is...
Yeah.
Yes.
Yeah.
No.
Yeah, it is.
Is it not 90?
Oh, yeah, it's 90. Yes. Yeah. 180 divided by that 2. Yeah. So it's 90. Good. And then the starting of the leaf equals 0. The length is 3. So which means when we graph that one, let me steal that. Now I'll make a new Cartesian plane. So when you graph that Cartesian plane, that is for cos. Okay, let me copy exactly this Cartesian plane and paste it and just twist it. Dilikan, even 9, like that. Yeah. Well, it's not that perfect, but it's fine. Then we say, okay, now I've got my list. I need to start from 0, but the length must be 3. All right. So which means here's my 0 degrees. Where will be the next leaf? 0 plus 90. The other one will be here at 90. Okay. You can put pi, don't worry. And then monarchy 180. The other one, Imoko 270. The length of it is 0, 1, 2, 3. It's going to end up got 3. The other one, 1, 2, 3. It's going to end up there by 3. The other one, 1, 2, 3. It's going to end up there by 3. The other one, 1, 2, 3. Is going to end up there by 3. Are we together? Ne?
Yes.
So we already have the spacing. So that means if we first Fongkong it ka pencil. I'm Fongkong it ka pencil. I said, okay, this one is itla mona. And then the next one comes here. Okay. And then the next one itla mo, the length of 3. And then the next one comes here. All right. Then you know it's gonna look like that. But when we start, you know it's gonna have to start here. I believe it's gonna come like that, and then it keeps on going like that. Then it goes like that without pause. You've got that. Is it making sense now?
Yes.
Good. Maraka kantungena ka sign. Then we need to find where it's gonna start because the other one never is starting. We need 90. Did I remove the start here thing? No, I can't remove. Yeah, I removed it last time. Yeah, so sorry about that one. So 90 over the B. I'm writing with a big thick pen. So what is 90 divided by 2? Give 45, ne?
Yes.
Yeah. So which means if I take the same Cartesian plane, let me paste it there. I'm pasting it here. And then I want to bring the 45. 45 will be that line there. It should be dotted. I'm putting that one because from here to there, key 45. From there to there, key 45. Do you see what I'm saying?
Yes.
All right. So the first one must start here. Remember the length key 3, itamo. The other one, normally it's about opposite sign. Because you come from here, you say from this 45, if I add from here to there, key 45, if I add another 45, imo. Oh, by the way, therefore, I'm thinking other things. Really well fancy one. All right, so we've got 4 leaves. Spaces, 300. You made me do something. You kept quiet. Spaces are runaki 360 divided by 4. Neki said the wrong number. Can say the location of the first one. I added this very same number. 360 divided by 4. Keep 90.
Yes, 90.
Yeah. And then the first one is 45 degrees. Yeah, there we go. So we're good now. All right. So the first one, we say it start here, go 45. So if I can draw that one, okay, the first one, imo. Then the spacing from this yellow to the next one, I must add 90 degrees. So obvious, you can see if you imagine a 90, to make 90 with those 2 yellow lines, itabakwa. So the next one will be there. Can you see that?
Mm-hmm.
You add 90, the other one, ilatala, the other yellow there, itabakwa. So when you add 90, the other one should be there on the opposite side, then even like this. All right. And then I know you guys, because you are not perfect sketch artists, you won't even do this. I don't think you'll even do this. We throw a katsila so. To draw it with one motion. No, it takes time. It's too much. They just wanted to see if you've got an idea. Risharp, ne?
Yes.
All right. Then you can do 5, 6, 7, 8, 10. Kaufele, any number. All right. Just remember the odd, the number of leaves are the same as the B, please. But more even, you double the B, and then the rest